Welcome to Pratidwani, where we try to humanize science. This is episode number 7, and we're going to discuss about two Chandrasekhars and many of their students who made outstanding contributions to science and technology. As you know, science and technology is something which is not only confined to laboratories, but also an important aspect of human endeavor. This means that the concept of doing research is not an isolated entity, but it happens with great amount of human interaction, and that human interaction leads to very interesting stories and also tends to bring its own history in how discoveries are made, how inventions are made, and how great thought can progress as a function of both space and time. So, today's topic is mainly about two important individuals and two men, and who played a very critical role in establishing certain school of thoughts. So we'll also discuss about not only their outstanding research, what they did, but also how they inspired many of their students. They also built a school of thought, as I mentioned, which sustains even to this day. And the question of their own trajectories, how people going abroad influences their research and research problem, and an important question of how history is mainly written from a male viewpoint. The issue of gender is very important while doing science, and this is something increasingly becoming evident that we have not paid a lot of attention to the pursuit of science in the context of gender. And you will see also when I discuss some of the students of these two gentlemen who played a very outstanding role and established a school of thoughts and many important institutions, also kind of expressing their opinion and talking about how science should be done in a way that it actually is applicable to all people irrespective of gender or any other kind of discrimination which is generally present in the society. Now, the important aspect also when discussing these things is the question of privilege, and you'll also see that the two Chandrasekhars not only played a significant role in establishing a great school of thoughts, but also they came from a relatively good background in terms of the economics. So this plays a very critical role in how science is done, what careers one can take, and this is something which we should also pay a lot of attention towards, because without some kind of a foundation laid by, let's say, family or some kind of association of the student with a particular place, it is generally difficult for them to really progress to places where they can do science with relative ease. And this is an important point which I would also try to emphasize. And of course, you will also see that how geography plays an important role in the pursuit of science. The two Chandrasekhars whom I'm going to discuss about had similar kind of upbringing, and they took different paths to pursue careers in science, and both of them became extremely famous, and one of them even went on to win a Nobel Prize. And the other one also established an outstanding school of liquid crystals in India, and the legacy still continues. But what is important for us to kind of identify is that these two gentlemen were totally dedicated to science, and there's a lot to learn from their career trajectories, and also the stories which their students tell is equally important for us to learn how these two outstanding individuals played a critical role. So these are all the things which I would love to discuss in this particular podcast. And before I go into the details, I would also want to mention that there are many references which I generally cite and talk about. I request people who are interested to go a little deeper into these references. As I keep telling, the podcast is just a window. It is important for us to go and explore a lot more and dive deep into the stuff what is now generally discussed as part of the podcast. So my request, especially for students, is to go and read the references and also try to understand the nuances behind all the things which are discussed within the podcast. Now, before we go further and discuss about the two Chandrasekhars, let me give you a bit of family history of the two Chandrasekhars whom I'm going to discuss about. Most of us probably would be aware of C.V. Raman. C.V. Raman is a very well-known name in Indian science. We also celebrate the National Science Day in commemorating his observation of Raman effect, specifically his observation and also the observation of K.S. Krishnan, who was his student who played a equally critical role in the discovery of Raman effect. But what is interesting is the two Chandrasekhars whom I'm going to talk about, were related to C.V. Raman. Okay, so Raman had a younger sister. Her name was Sita Lakshmi, and she had 5 sons. Okay, among them, 3 of them became very well-known scientists. One of them was Shivraj Ramasheshan, a very renowned crystallographer who also played a very critical role in establishing institutions, including schools of thought in crystallography in IISc and Indian Academy of Sciences. And he also is one of the very important kind of historian who gave a lot of information about many people who made interesting discoveries, especially related to Raman and his legacy. The second person among the 3 sons was a person called as Sivaramakrishna Chandrasekhar, who is one of the Chandrasekhars whom I'm going to talk a bit about. He made outstanding contributions to liquid crystals and ended up kind of establishing one of the most important schools of thought in soft matter physics, which has to come from India. And the third brother within this particular trio is the great Pancharatnam. So many of you probably would have or would have not heard about Pancharatnam, especially people who work on berry phase associate Pancharatnam berry phase, and this is the same Pancharatnam. He was brother of the Sivaramakrishna Chandrasekhar, whom I'm going to talk a bit about, and hopefully I'm going to do even a podcast on Pancharatnam at some point of time because the story itself is very interesting. And so these are the 3 scientists in the family, and these are 3 sons among the 5 of Sita Lakshmi, who was the sister of C.V. Raman. C.V. Raman also had a brother, and his name was C.S. Iyer. And his son was the great Subrahmanyan Chandrasekhar, whom we all know, the astrophysicist who also won the Nobel Prize, and probably one of the greatest names in the mathematical astrophysics, who played a critical role in not only establishing various different sub-areas within astrophysics, but also was very well known for the style of his research, where he contributed very deeply and widely to various different sub-areas of astrophysics. And his legacy still remains kind of across the whole world, including in India, where many of his students have played a very critical role in establishing very interesting schools. Now, what is important for us to emphasize here is that you can see that C.V. Raman's brother and sister's children are also kind of exposed to science because it is very important for us to recognize that they came from a family which was associated with the civil service in British India, which means that during that particular period of time, people who were employed in the civil service of British India were relatively well off, which means that they had exposure and also access to good quality education, which many of the Indians did not have. This is something which we don't generally discuss, especially when we go back to that period of time. It is important for us to recognize that they already had a good platform for really doing or taking up careers which are not very easy for a common Indian to take up during that particular period. So therefore, both Chandrasekhars were born in a family where there was relative privilege in terms of the education and the quality of the education. Both were educated in English medium schools, which was again a very big privilege during pre-independence era, or roughly around post-independence era, in the case of Sivaramakrishna and Chandrasekhar. So this is something which is also very critical for us to see how this kind of privilege played a critical role for them to not only getting access to important kind of scientific literature, but also help them to go abroad. For people at the cusp of the Indian independence, which is 1947, it was not very easy for people to be mobile, especially if one needs to go abroad. One needs to have some kind of a privilege. And you can see both of them had this particular privilege. Nothing to take away the great contributions they made, but what I'm trying to establish here is the fact that they came from a relatively good background in terms of economics, which had a deep kind of impact on what they could do in their careers and how it influenced their career trajectories. I should also mention that directly or indirectly, C.V. Raman had a very important effect on these two individuals. These two individuals, of course, were nephews of C.V. Raman, so they had access to some kind of a scientific background and even some cases literature. And in case of Chandrasekhar, there was also a mentorship in terms of the work, what he did. In fact, he did a bit of research with C.V. Raman, and you'll see how that played a very critical role going forward. So, to establish the foundation, the two Chandrasekhars came from a relatively kind of privileged background where they had access to science education, which played a very critical role. Remember, even C.V. Raman himself actually had access to good education, good quality education. That equally played a critical role in him becoming aware of the scientific literature. He also was an outstanding student. Similarly, the two Chandrasekhars whom I'm going to talk about were also very good students and had very deep interest in science. This is another important aspect which I would like to emphasize. If there is a lot of scientific discussion and science communication, which is importantly part of, let's say, dinner discussion or something which you generally discuss in your home, that kind of percolates into the mind of children who are growing up in such an environment. Therefore, I always generally tend to emphasize that it is important for children to get exposed to science and technology at a reasonably early age, where the curiosity of their minds actually are really enhanced when they get exposed to either natural phenomena or some kind of devices. And you can see the children really grasp a lot of interesting concepts through important questions. And such questions have to be constantly encouraged. And I am very sure that all these people did have such kind of a background. And if you also have noticed, a lot of things actually are related to the male, which means that the gender also plays an important role. Although these men came from very privileged background, you would also see that it is also slightly more male-centric, which is a reflection of the times in which they were growing. And you'll also observe a lot of history, especially scientific history, over the centuries, mainly written from a male viewpoint. This is problematic because it tells the kind of viewpoints only from a particular kind of vantage point. But it also misses a lot of important details, and it doesn't really consider the kind of large umbrella of people who may have kind of played a very critical role. So the privilege of economics, the bias of gender, all these things have played a very critical role in establishing the history of science. And mainly the history of physics, if you have observed, is also very male-centric. If you read, let's say, Manhattan Project, everything you read about Manhattan Project is mainly from is from a man's viewpoint. There are a lot of stories which may have not been told, and which is necessary. I think there is a lot of effort nowadays going on, including in India, where there are many interesting kind of projects which have been taken up. The readily one project which has come to my kind of attention, and I have been reading quite a bit about that, is the Lilavatis' daughter, which is an outstanding book written by two individuals who are very good scientists in India, Professor Sivaramakrishna and Professor Rohini Godbole, who have put together stories of many researchers who have played a very critical role, especially female researchers, and who have established outstanding kind of stuff within Indian context, and their stories have been beautifully kind of made into a book. There's also a recent book called Lab Hopping, which is equally interesting, and I've been reading that book, which chronicles the stories of female researchers in contemporary India, and has some very, very interesting kind of highlights of people. It also emphasizes what kind of problems females actually have to undergo to really do science in India, and hopefully I would like to emphasize this going further in the podcast at some point of time. So coming back to the two Chandrasekhars, these two gentlemen now are kind of well educated, meaning they actually have good solid foundation. Subrahmanyan Chandrasekhar was born in 1919, and the other Chandrasekhar, who also was born into this particular family, the date of his birth is 6th August 1930. So these two people went on to also do their undergraduate studies in India, and also had some very interesting exposure to research at very early age. So let's start with Subrahmanyan Chandrasekhar. So Subrahmanyan Chandrasekhar's biography is very well kind of documented. Kameshwar Wali, who is also a researcher in nuclear physics, has written a lot about Subrahmanyan Chandrasekhar. I'm going to give the references to his books on Chandrasekhar in the show notes. And Wali was himself a researcher, a physicist, who also chronicled a lot of things done by Subrahmanyan Chandrasekhar. And a lot of things what I'm going to discuss will be mainly from the sources what I have read from his books, which are really interesting, and also gives a beautiful overview of Subrahmanyan Chandrasekhar's personality, and also his scientific biography in terms of what he did, and how he thought, and the legacy he actually has left for his students to continue. And this is something I would also want to kind of emphasize a little bit more. So Subrahmanyan Chandrasekhar had a very good exposure to science at early age, and so much so that he met Arnold Sommerfeld when he visited India, and had a very interesting interaction, which is also very nicely chronicled in G. Venkatraman's Raman and His Effect, and other particular kind of small books, including Chandrasekhar and His Limit. So Chandra had very good exposure to these kind of scientific literature. He was already kind of thinking about quantum mechanics at an age where undergraduates were still learning some basic physics, and he had the confidence to go and talk to Arnold Sommerfeld about the theories he was trying to postulate, and Arnold Sommerfeld gives him leads into understanding quantum mechanics in terms of the revolution which was happening during 1930s, and where he does mention that there is a new kind of emergence of the concepts of wave function, etc., And Chandra is fascinated by that particular kind of interaction, and he dives deep into this particular literature and tries to understand. Interestingly, when he is now embarking on to a trip to England, where he is now moving to Cambridge to do his PhD and research, he kind of comes up with an important discovery which would actually change the course of how astrophysics is done. In fact, at a very young age, doing research on that ship dock, he comes up with now famously called as Chandrasekhar's limit, which is actually a limit in terms of the size of the star in comparison to the size of sun, where if you have the size of the star, which is 1.4 times greater than the size of the sun, then that particular star kind of trajectory in terms of its life changes, and if it is less than 1.4 times the mass of the star of the sun, or the mass of sun, then it actually takes a specific kind of trajectory. So if I have to give a slightly more accurate kind of definition, Chandrasekhar limit is the maximum mass of a stable white dwarf star. The currently accepted value of Chandrasekhar limit is about 1.4 times the mass of the sun. Okay, this is a kind of a couple of lines from Wikipedia, but there are also important textbooks where you should go and explore if you are interested. The physics of that particular calculation is equally interesting because it brings in quantum mechanics and couples that to astrophysics, which is an important kind of coming together of two vital concepts in physics. And it is fascinating to see how young Chandrasekhar made this beautiful connection when he was such a young student. This is something which is totally astonishing. But what is interesting is that once Chandra goes to Cambridge, he's now taking courses from Dirac, and he's interacting with very big people like Fowler, who also will become his mentor. And he also has very deep interactions with Arthur Stanley Eddington. So Eddington was like, big dada of astronomy and played a very critical role, an influential role in kind of confirming general theory of relativity of Albert Einstein through his famous expedition of looking at the deviation of the star because of a very heavy mass. And that was predicted by Albert Einstein as part of his general theory of relativity. So Eddington he plays a very critical role in Chandra's life. In fact, kind of also a negative role in his life, because when Chandra would have postulated this particular principle and a kind of a mass cutoff for how large the star can be in terms of the classification, Eddington openly ridicules Subrahmanyan Chandrasekhar. This would have a very deep impact on the way science is done by Chandra, because Chandra goes on to say that this really critically played a role in how to look at science as a human pursuit, because this has a huge impact, because Eddington was his hero, and at an young age he gets kind of ridiculed by Eddington for coming up with this particular hypothesis and kind of proposing this theory where it turned out to be correct, because Chandra's calculation turned out to be absolutely correct. It was one of the outstanding achievements in astrophysics, and Eddington was proven wrong. But the sociology of science is such that if there are extremely dominant individuals in science, unfortunately their viewpoint gets a lot more attention than somebody who may not be very famous or who may not have established their careers. I'm not saying that always there will be something very important by people who are not established, I'm not making a case for that. But what I'm telling is that there's a lot more emphasis given for people who are already established. And this is true even today. Okay, there are a lot of things which you will observe where even media and even science media, including big places like Nature, Science, other kind of journals, tend to take commentaries from people who are already extremely well established. Undoubtedly, there are many experts, but there also are many viewpoints which are mainly dominant from a particular kind of school of thought. And that diversity has to improve, especially in big ticket journals like Nature and Science. A lot of commentary comes from people who already have a kind of a large voice within the scientific community. This is something for us to think a lot about. Now, going further, Subrahmanyan Chandrasekhar also played a very critical role, as I mentioned, in establishing a kind of connection between astrophysics and quantum mechanics. And this is also because he had this very good exposure to quantum mechanics in Cambridge, because he was a student of Dirac. He also took kind of classes from Dirac, although Fowler was his PhD advisor. And he goes on to do some outstanding work. He also gets exposed to some very intense amount of mathematics, which continues to play a critical role all throughout his research career. Because Chandra at some point of time had deep love for pure mathematics, mainly because he was extremely motivated and inspired by Ramanujan, who is another legend whom we're going to talk at some point of time in the podcast later. He played a very critical role in inspiring Chandra. Of course, I don't think he came in contact with him, but Chandra was deeply influenced by mathematical thinking. And this is evident in all his work. And Chandrasekhar then moved from UK to US and moved to Yerkes Observatory in the US, where he played a very critical role in establishing the School of Astrophysics, which was upcoming in United States of America. And of course, Chandra also went on to become a professor at University of Chicago, where his legacy is very well known and very well documented. And Subrahmanyan Chandrasekhar had a unique style of working on a research problem for a reasonable amount of time, let's say 10 years or so, and then writing a definitive book about the topics of interest, what he was working on. And his book on radiative transfer still remains one of the classics in scientific literature, not just in astrophysics, but the whole of scientific literature. And the clarity with which he writes his review articles and his books is something to learn from and to emulate. My own experience of reading radiative transfer book came when I was a MSc student and I was doing my summer kind of research as an MSc student at Indian Institute of Astrophysics. The late Professor Nagendra was the one who introduced me to radiative transfer. And since I was always interested in optics, I learned a few things from that book, and it was an eye-opener in clarity and in terms of rigor. And the way Chandra wrote was so crisp and clear. That is something which is a great lesson for all of us to emulate. So in that way, Subrahmanyan Chandrasekhar really kind of established so many important areas within physics, especially in astrophysics. And he took inspirations from various different parts of physics and tried to integrate that into astrophysics. And that is something which is evident all throughout his career. Now, what I want to do is I want to give a kind of a highlight of what his students thought about. Okay, I personally had direct contact with one of his students, Professor G. Srinivasan, when I was growing up in Bangalore and during my undergraduate days and MSc days. And I consider him as one of my mentors who played a very important role in kind of inspiring me to take up science. And he used to tell wonderful stories of Subrahmanyan Chandrasekhar. He himself was an outstanding student. During the undergraduate times, I did a rotation curve experiment in Raman Research Institute using the radio telescope, which kind of is an important observation of 21 centimeter hyperfine line of the hydrogen, which also gives kind of an indirect kind of clue towards the presence of dark matter. And that is a beautiful experiment. And Professor Srinivasan used to talk a lot about Chandrasekhar, his legacy, and the way he used to interact with students, and various interesting aspects of it. But what I would like to highlight is some specific inputs what I have read from another of students of Subrahmanyan Chandrasekhar, which is Professor Bimla Buti. And she was one of the female PhD students from India who went from India to University of Chicago and did PhD with Chandrasekhar. And she has a lot of interesting kind of praise for Chandrasekhar and the way he influenced. And she calls him her guru. And Bimla went on to establish some outstanding kind of things related to plasma physics in India. And the Lilavatis daughter has a beautiful chronicle of her own journey. And I would strongly suggest you to have a look at it. And you can see I am also trying to project these people from not only a male viewpoint but also from a female viewpoint, because that is equally important, because they have very interesting stories to tell and a different viewpoint to also bring in, which is equally critical when one is doing science. And let's see what Bimla has to say. My association with Chandra started as of a guru and a shishya. In 1959, Chandra was giving a course in quantum mechanics, and I, as a graduate student at the University of Chicago, took this course for a credit. This was the beginning of our interaction. Chandra, in fact, gave 2 courses in quantum mechanics. These were the best courses I had at the University of Chicago. He was an absolutely superb teacher. All of us, that is the students in his class, used to be spellbound. Then, when it came to choosing the thesis advisor, I decided to work with Chandra. This indeed turned out to be the greatest decision of my life. However, before officially accepting me as his graduate student, Chandra had frankly told me that because of too many commitments, he would not be able to devote much of his time for me, or for that reason, any of his graduate students. Nonetheless, I accepted the challenge of working with him. So Chandra gave me a few references to 2 papers and asked me to go through them. A week later, Chandra used to visit Chicago campus only during once in a week. From Yerkes Observatory, which is about 90 miles from Chicago, he would drive on Thursday morning, stay overnight at the International House, and drive back to Yerkes Observatory on Friday evening, where I saw Chandra. And I told him what was lacking in those 2 papers and how one could proceed to take care of those 2 shortcomings. Surprisingly, this turned out to be a major part of my PhD thesis. Stop quote. Now, Chandra's legend is that he used to come from Yerkes Observatory to Chicago campus, driving all the way around 90 miles. And there's also a very interesting anecdote that he used to come and teach. And in one of the class, he had only 2 students. And those 2 students were Yang and Lee. And the surprising aspect is that those 2 students, Yang and Lee, went on to win Nobel Prize. And Chandra used to tell, it seems, that it was really worth coming all the way because my whole class got Nobel Prize. So that was his commitment to science. And as you can see, Bimla also actually plays a lot of tribute to Chandra towards his commitment towards science and how he played a critical role. So she also further tells about the way he trained students. So for example, she says, start quote, The University of Chicago had a rule. It required the PhD thesis to be based on papers published by the students under his name only. For this reason, unfortunately, I did not have any joint paper with Chandra. In spite of he not being a co-author of any publication of his graduate students, he would not let us submit any paper for publication or submit the thesis till he was absolutely satisfied with the detailed calculations. Stop quote. So you can see that he established a very rigorous program of training his students, and he used to also conduct seminars and ask his students to give talks, especially during the evenings, and get a grasp of what exactly the student is doing and give them the feedback and tell them what is necessary and what has to be done. And she continues to say, start quote, Chandra was a great mathematician, a great physicist, and probably the greatest astrophysicist. His classic paper on stochastic problems in physics and astronomy in Review of Modern Physics 1943 is a crystal clear witness of this statement. Stop quote. In fact, I totally agree with this particular statement because I have read this Review of Modern Physics paper, because Chandra is trying to establish a beautiful connection between Brownian motion and astrophysical processes, because stochastic problems essentially are related to Brownian motion. And my own research on some aspects of Brownian motion in the context of optical trapping and optothermal electric trapping brought me to those papers, and I totally kind of second the point what Bimla is making here, because the clarity with which Subrahmanyan Chandrasekhar wrote was really outstanding. So you can see Bimla's kind of experience was really great, having worked with Chandra. Chandrasekhar did play a very critical role in kind of influencing a lot of his students, the way they did research and what they could go on to do, because Bimla herself actually came back to India after doing research in US, came to Delhi, IIT Delhi, and then she meets Vikram Sarabhai, and then he tells her to come to PRL, which is a physical research laboratory in Ahmedabad, which is an outstanding kind of research institute in India. And there she goes on to have a career spanning over 23 years, and then further goes on to establish the Institute of Plasma Research in Gandhinagar, where she played a very critical role. And now she is in Delhi as per the note written on the Indian Academy of Sciences, and she has a foundation which also is kind of supported by her. And she tells about Chandra, start quote, I can go on and on with many more stories, but I must stop. Before concluding, however, I would like to say once again how fortunate I was having Chandra's first as my guru and later as a very kind and generous friend. My admiration for him only grew with time. I learnt a lot from him, and even though he is no more, and she is writing during his obituary, I will keep learning from the outstanding literature that he has left behind us. Thanks a million, Chandra. Stop quote. Now, this is a great tribute by a student to her mentor. And I would strongly urge you to read more about Bimla Buti also, because she is indeed one of the great Lilavatis' daughter. And we need to read a lot more about Indian scientists, especially female Indian scientists, who have played such a critical role in building the ecosystem of science and technology within India. And Bimla Buti is a great example for that. And I would strongly suggest you to have a look at it. So this is to do with Subrahmanyan Chandrasekhar, the astrophysicist. Now let's actually turn towards the Sivaramakrishna Chandrasekhar, who also is the other Chandrasekhar whom we're going to talk about. And Sivaramakrishna Chandrasekhar, that is his full name, by the way, was an important person to establish a great school of soft matter physics in India. Okay, so he was also, to begin with, a student of C.V. Raman, and then he later moves to Cambridge University, to do his PhD, where he gets his PhD around 1957. And he works on some interesting properties of X-ray diffraction, where he really gets excellent training and exposure to utilizing X-ray diffraction in unveiling the structure of matter, which still remains one of the most powerful tools to do so. And he's an experimentalist, by the way. Okay, he really has excellent training in understanding how to use X-rays to unveil the nature of matter. He was also very deeply influenced by Bragg, of the fame of Bragg scattering and Bragg reflection and X-ray diffraction. So he kind of gets a viewpoint of unveiling structure of matter, utilizing tools which are emerging in the modern day technology then, and X-ray was indeed one of the most important thing. Now what he does is, as I told at the beginning of the podcast, the choice of the problem is equally important to work on, and not only how you work on and what particular problem you work on. So what Sivaramakrishna Chandrasekhar does is he moves back to India in 1961, and he goes to a newly minted physics department in University of Mysore. Okay, and there what he does is he starts research on something called as liquid crystals. So for people who don't know, liquid crystals is a very interesting state of matter which is kind of in between liquids and crystals. Okay, so there is some kind of a short range ordering in liquid crystals, but it is not as rigid ordering as what you see in, let's say, a solid crystal. But it is neither something which is similar to liquids, which have hardly any kind of ordering, if any. And liquid crystals were kind of a curiosity because they showed some very unique properties, especially optical properties, and people were very intrigued. In fact, great Digenes also was intrigued, who, by the way, Digenes went on to win a Nobel Prize in 1992 for some outstanding work what he did. And Subrahmanyan Chandrasekhar also had some very interesting ideas in terms of the stochastic process, which had some very interesting connection to Sivaram Chandrasekhar's work, because there are some interesting questions nowadays. Of course, they did not interact per se, at least to my knowledge. But what I can say is that there are some interesting questions nowadays which are emerging, where the stochastic process what Subrahmanyan Chandrasekhar gave can be applied to the research what Sivaramakrishna Chandrasekhar did. So there is some interesting kind of emergence of concepts and kind of intriguing questions which are there. So coming back to the liquid crystal research, so in the University of Mysore, they start kind of a program where they are now using X-ray diffraction to unveil the structure of matter, especially the liquid crystals. And about 1971, Sivaram Chandrasekhar kind of moves to Raman Research Institute, which is now already an established laboratory in Bangalore, and then starts the program in significant kind of might. And lo and behold, even to date, the liquid crystal laboratory, the soft matter research group in Raman Research Institute, actually has great kind of prominence in the world for the work what has been done. The most important thing about Sivaramakrishna Chandrasekhar's work there was the discotic liquid crystals, where the columnar phase of the so-called discotic liquid crystals were discovered, and which is a very, very important discovery. This is kind of part of the history of liquid crystals. So liquid crystals comes in various different varieties, like pneumatic, smectic, cholestric, etc., etc. I'm not going to go into the details, but what is interesting is that in Chandrasekhar's research, they found that unlike the conventional rod-shaped molecules which formed liquid crystals, they found that the discotic, disc-shaped molecules could also form liquid crystal kind of architecture, where they form the columns in a specific geometry, and this was established by the group. And this turned out to be one of the very important discoveries in the context of liquid crystals. Now, as you probably would have heard, liquid crystals are extremely important technological materials because a lot of display technology is based on liquid crystals. For example, spatial light modulators or some kind of digital displays actually use the property of liquid crystals which are sensitive to external perturbations. So, for example, you can have optical perturbation, electrical perturbation, magnetic perturbation. So, the orientation, the assembly of the molecule can change according to the way you apply the external perturbation. So, whenever you want to have some kind of flexibility in terms of display, for example, then you would want some kind of an external perturbation to be used, which can be harnessed for various different applications. So, Sivaramakrishna Chandrasekhar established this great school of liquid crystals, and a lot of his students played a very critical role. And I had the privilege again to interact with one of his outstanding kind of students, Professor G.S. Ranganath in Raman Research Institute. Ranganath himself was an outstanding lecturer and gave great talks. He also has written a beautiful book on mysterious motion and intriguing phenomena in physics. It's a fantastic book. During my undergraduate days, I used to go and interact with him, and he used to give me small physics puzzles to solve, and the time he assigned was a week, and I used to go back to him along with some of my friends and discuss some very fascinating and interesting phenomena in optics, thermodynamics, and various different classical physics. And this is something which is very, very important for us to really understand that classical physics is equally important. So, Chandrasekhar also went on to write a very important book on liquid crystals. That was one of the first and the most important books written on liquid crystals, along with Dijean's book on liquid crystals. Those two references are still the classics in soft matter physics. If somebody is interested, I would strongly urge you to have a look at it. That particular book also establishes very beautifully how experiments and theory can be brought together. Dijean's was a theoretician, whereas Sivaramakrishna Chandrasekhar was an experimentalist who had a good exposure to theory, and you can see that in his work too. We're trying to kind of bring in the abstract and connect it to the realistic experimental observations is not a trivial thing, and his book beautifully does that particular job in a very effective way. And I should mention that his own students have went on to do some outstanding work, like K.S. Suresh, G.S. Ranganath, Madhusudana, and so many people from his laboratory have gone on to do some important work in liquid crystals. They are very well known name in soft matter physics, not only in India but across the world. So Chandrasekhar did really have an important role to play. And one of the aspects which you will also find is that this establishment of liquid crystal research needs important kind of input from chemistry. And this is something which is very critical for us to appreciate, especially if you are doing work in a laboratory. Even if you are doing physics research, it is equally important for one to understand some basic chemistry and engineering and other aspects of it. And generally there is a notion among students, especially physics students, that chemistry may not be important, but that is not correct at all. In fact, if one needs to do good quality physics, especially in the laboratory, and no matter what physics you are doing, it can be even high energy physics or optics or of course condensed matter physics, this needs a little bit of understanding of chemistry. Without that, you would be not able to understand many different concepts, and that is very critical. And therefore, generally, especially for students, I always kind of encourage them to get good exposure in basic foundational chemistry, even if you are deeply interested in physics. That will serve you very well. And in fact, some of my colleagues who do very interesting research on condensed matter physics, both soft condensed matter and the so-called hard condensed matter, have excellent understanding of chemical structure and crystal structures, etc. And you can see that really comes from great kind of depth and understanding of basic chemistry. And therefore, I would strongly urge students to really pay attention towards all these aspects of doing research in physics. So, to conclude, what I want to say is that Chandrasekhar played a very critical role in liquid crystal research. He has a legacy which is still continuing. If you go to Raman Research Institute, there's a very nice soft condensed matter group which I think you should have a look at. And they're also doing some very interesting research there. And in the broader context, the two Chandrasekhars whom I have discussed about, if you look at it, they came from similar backgrounds, but their trajectories were very different. One became an astrophysicist, the other became a condensed matter physicist, including soft condensed matter, and established an important school of thought. Both these people played a very critical role, but I also want to emphasize that they came from a relatively privileged background. So therefore, one should be always a bit cognizant about the kind of upbringing which these great scientists have had in the past. Now, there are many interesting stories which probably have been untold, where a person came from very humble background. One of the exceptions is Ramanujan, who came from a relatively kind of less well-to-do background. But as you know, he is a genius in that sense. He went on to do some outstanding work within such a short period of his life. And Ramanujan is a great example of how people without some privileges can still do some groundbreaking work. Just that we have to discover such people and understand that science actually doesn't discriminate among various different aspects of society in terms of economics or gender or anything. It's kind of an equal opportunity provider, and therefore that is another reason why science and scientific research is so important, because it is basically connecting to the human curiosity, and therefore it is very important for us to encourage people to understand science irrespective of their age. And this is something I keep telling always, because we should not keep science only as an activity for students. It is very important that science becomes a day-to-day kind of a conversation at every part of one's life, and that is equally important for us to develop as both a nation and also as a humanity, because it is one of the important aspects which will continue to be very critical down the years all throughout our lives, and therefore we should encourage science. This also highlights an important aspect. You see, we are now talking about people who are dead. Both the Chandrasekhars are no more, but we still talk about them, and that is, you can see that the legacy what they have left for us to discuss about is mainly because of science, and that is an important lesson. If one really is doing some good work, that work may or may not be recognized right away, but down the line, if the quality of the work is good and if that person has really impacted the scientific community through his or her students and also the kind of local and global environment, then generally their legacy is always established. Which brings me to a very interesting quote by Subrahmanyan Chandrasekhar, which is apt at this particular stage to be mentioned about. So the Chandrasekhar himself had a great legacy of giving lectures. Subrahmanyan Chandrasekhar especially, he gave some outstanding lectures not only about science but also about how to perform science and scientific pursuit. And Kameshwar Wali, whom I quoted earlier, who is also official biographer of Subrahmanyan Chandrasekhar, writes, quote, Chandra often quoted from a letter of his friend Edward Milne during his Cambridge years. Start quote. Posterity in time will give us our true measure and assign to each of us our due measure and humble place. And in the end, it is the judgment of posterity that really matters. He really succeeds who preserves according to his lights, unaffected by fortune, good or bad. And it is well to remember there is no correlation between posterity and the judgment of contemporaries. Stop quote. So this is a crucial factor what he is mentioning. What he is telling is that the posterity, which is what one sees in the future, how people judge and how people judge at the current moment need not have any correlation at all. And this is something which is profound, because a lot of people generally tend to get caught up in what people think about their work in the contemporary time. But how people judge over a long period of time is equally important. And there is an important lesson for all of us to learn from this viewpoint of Subrahmanyan Chandrasekhar, that posterity is what is important in how a person and her or his legacy is judged. And there is an important aspect which we all can extract from this particular viewpoint. This brings an end to the episode number 7 of Pratidhwani, where we try to humanize science. I hope you are enjoying the conversation, what I actually am doing. I also hope to kind of expand this and bring in some guests onto the show. And I'll update you as and when that is going to happen. I am also on Twitter and some other platforms, including Facebook. If you are interested in connecting with me and giving your feedback on the podcast, you are welcome to do so. And as I say, Pratidhwani is a non-commercial podcast done purely out of my own kind of interest. So feel free to share this podcast links to various different people. Pratidhwani is available on Spotify and Google Podcast, and the link can also be found on my blog post. So all these 3 platforms are easily accessible, and I also hope to put the same episodes on various different platforms. So until next time, bye-bye.